Example number 6, we want to wrap another function with a whole. So all of x I already factor, and you can see that the x minus 2 cancel out. That will give you a whole, and we will plug in the whole for later. It means that the function r of x in the simplified form will be 2x minus 1 and x plus 2. So you will continue to wrap the function r of x in the simplified form. At the end, you will plug in the whole. You do not need to go back to the original function. Okay, we will continue make the wrap from the simplified form. The domain, step number 1, before we simplify, is all real number except for x equal plus minus 2. And then step number 2 is the simplified step. The r of x in the simplified step is 2x minus 1, x plus 2. And again, we will wrap this. That means when we use the table, we will look at that function to plug in the number for later. Step number 3, we will find the vertical asymptote. The vertical asymptote, we will set the bottom equal to 0 and we solve for the x. So the vertical asymptote is x equal to negative 2. The horizontal asymptote or the oblique. We look at the dd. The dd for the x is 1. The dd for the x is 1. So the horizontal asymptote will be the number in front of the x of an over bn. So we have the horizontal asymptote in this problem because we have the case that m equal to n and is equal to 1. The horizontal asymptote is 2 over 1. You can simplify and you got the answer is 2. Now I will begin to do the wrap for this. We will wrap the vertical x equal negative 2 and the horizontal is y equal to. Then we find the points. In step number 5, we will find the intercept. For the x-intercept, we will let y equal to 0. That means r of x equal to 0. So 2x minus 1 over x plus 2 equal to 0. For this fraction to be 0, the top have to be 0. We solve for this equation, we get x equal to 1/2. So that will be the x-intercept. So we have 1/2 is this point right here. We have 1 is right here. And then we find the y-intercept. We will let x equal to 0 and we input that 0 into the function. We have 2 times 0 minus 1 divided by 0 minus 2. Then the answer is 1/2. The problem is 0 plus 2 in the denominator. So the answer is negative 1/2. It's not positive 1/2. Okay, now we need to make additional points. We need to make the points in, let's continue making more points, but starting from the left hand side, we need to make the points between the x-intercept and between the vertical asymptote. So from this one, we will make negative 3. So when we input negative 3, we will get positive 7. So the point negative 3, 7 is right here. And then we need to make the points that near the vertical asymptote. So on the left side of x equal negative 2, we will make negative 1.2.1. And when you input negative 2.1 into the function, you will get a very big number. I'm going to leave this for you to do. So then we will continue to draw the curve from the point to the vertical asymptote that go up. And then we may have something like this. To be making sure, you need to make points like negative 4, negative 5, and so on. Okay, so I skipped a step for you, but we know that the answer will be approach to the horizontal line. And then we will make the points that is between the vertical asymptote and the x-intercept, which is 1/2. But you look, we already have the y-intercept between that vertical and that point. So we already have. So the point is x equal to 0, 1. So you don't have to make the points. Then you connect these 2 points. And then to make the one that near the vertical asymptote, you're gonna make negative 1.9, and you will get a very small number, like negative small number. Okay, then you can make the curve that approach to the vertical asymptote in the bottom, like this. And then we will make the points that from the right side of the x-intercept. We will make line 2. So when we make 2, we will get 3/2. And we can make 3, we can make more. So we have 2 times 3 minus 1 divided by 3 plus 2. Then we got 6 minus 1 is 5/5. So we got the answer is 1. 3/4 when you make 2. Then this is like 0.75. So 2, 0.75 So 3,1. So we can connect them like this, and then we know that it's approached. It may touch, we will check in about that later, but we need to go back and check about the hole. You keep in mind that before you cancel the x minus 2, remember right here, we cancel out the x minus 2, and we say that when you cancel, that will give you the hole. So the hole will be at x equal to 2, and I already calculate that point. So that point is not a point on the graph, but that will be the hole. So we're gonna make the hole right here. And lastly, so far we look at the function and we did not know the function may touch the horizontal line. It may and may not. So we don't know which one. In order to know if it's touching it will be intersect at a point or not, we will solve for the system. We write down the equation of the horizontal line is y equal to 2 and the function r of x, which is y equal to x minus 1 divided by x plus 2. We will set both of them equal of each other. And then we multiply both sides by x plus 2. And we can do that is because we already found the domain before, that we exclude the x equal to negative 2. Then you distribute for the other side. You minus both sides to solve for the x. But what happened is that the x is gone. You left with the statement negative 1 comma 4. This is the fourth statement. So basically you cannot find the x so that the two functions they meet of each other. So in this case, you can conclude that the graph does not cross or does not touch, does not intersect the horizontal line. So basically your graph right here is done. And you can continue to draw the curve, and it's just approach but no touching the y equal to 2.